All right, and this is the history of the atom, and we're going to go in chronological order. So first we have Dalton's atomic theory, and this was created by a dude named John Dalton. Now his model of the atom was something known as the solid sphere model. So it's basically just he thought that atoms were just hard indivisible spheres, and he created all of this right over here. You can read it on your own. But basically, a lot of these kind of theories that he made about atoms actually were true, and they still stood up to this day. So considering that they didn't really have much info about the atom back then, these were pretty good assumptions. Now then you have J.J. Thomson, and this is sort of the chocolate chip cookie or plum pudding model of the atom. And he discovered the electron. So basically he thought that this outer sort of cookie right over here is positively charged. And through his cathode ray tube experiment, he discovered that there were these kind of electrons which were negatively charged, right? Electrons which were negatively charged. So you can imagine all of these negative charges right over here, and they're just sitting in like a pile, this one clump of this positively charged thing. Now, this wasn't entirely true, and then a dude named Ernest Rutherford improved on this model, and actually you might see this model. He did the nuclear model of the atom through his gold foil experiment. So you want to know these terms, right? So this is, J.J. Thomson discovered electrons through his cathode ray tube experiment, and Ernest Rutherford discovered the nucleus, and he discovered that atoms were mostly empty space through his gold foil experiment. Then you have Niels Bohr, and he discovered that, you have like the nucleus, right? It's in the center, but then it's in the center of the atom. But then you have these sort of shells right over here, and these are kind of fixed paths where electrons can sort of orbit around this nucleus, which is sometimes why it's known as the planetary model of the atom, right? Because it's like a solar system, right? You got the sun in the center, and you just have these kind of electron sort of rings orbiting around it, right? And the thing is, if an electron gains enough energy, it can move up to another shell, right? It can move up to another shell with enough energy, and then when an electron eventually falls back down, in this case, it goes from the third shell to the first shell, right? And when an electron eventually falls back down, it's going to release this energy that it absorbed as light, all right, or photons. All right, then finally you have Erwin Schrödinger with the quantum model of the atom, and basically he discovered orbitals. Describes the regions where electrons can be found. So all of this kind of dots I've drawn here represents a location that an electron could be. And notice how it's more likely that an electron is near the nucleus than, very far away from the nucleus, right? Because electrons are negatively charged, nucleus is positively charged, they attract each other, so it makes sense that electrons want to be close to the nucleus. And that's all. This is also called the fuzzy cloud model, I guess you could say.